In addition to new sophisticated polarization device types, we need sophisticated polarization measurement capability. The Poincare Sphere Visualization Tool is a tool which runs in the 3D viewer, which indicates characteristics that are important and useful in analyzing polarized ray fields. The way we open a ray set in the Poincare Sphere Visualization Tool is first to dump that ray set using the Jones vector format for polarization, and then use &view to read the file into the 3D viewer. So this is the 3D viewer running the Poincare Sphere Visualization Tool. There are a few things worth noticing about this. First, we don't just have polarization information here. We have wavelength information encoded in the shape of the markers. We have the ray flux encoded in the color of the markers. And of course, we have the polarization encoded by its position on the Poincare sphere. The top pole, or north pole, is the right circular polarization state. The bottom pole is the left circular polarization state, and the equator are linear states of various orientations. We can change the way the flux is mapped from linear to logarithmic flux mapping by simply selecting the logarithmic radio button and hitting apply. Of course, we don't see anything happen without changing limits. We have three populations in terms of flux. We have some low flux rays around the equator, and all of the others are at least somewhat higher. So if we want to cut off the low flux rays, for instance, we might set the minimum to 0 in log space. And of course, the rays around the equator, which I said were low flux, disappear. If we wanted to take a look at the high flux ray, or the low flux rays only, then we might reverse that and set the max to 0 in log space. So now we see the rays around the equator, which, as I said, are linear states. And if we want to take a closer look, one thing we might do is simply select one with our mouse button. We see the ray number in the dump file, its flux, wavelength, positional and directional coordinates, and its polarization information. If we'd like to save that information, we can use Control in the left mouse button to highlight that rays marker, and then to send it to the output window, we simply hit Display Polarization Information. That's a right click in the open area in the toolbar, and then Display Polarization Information. And in the output stream, we have all the information that occurred when we highlighted, but actually saved in a way that we can look at later. If we want to save this directly to a file, we can use the Save Polarization Information option, give it a name, and we'll save it as a text file. There are many ways to alter the basic appearance of the Poincare Sphere tool. One further option that might be of interest is to turn off flux mapping altogether. If we want to see all of our rays again, we could change these limits, but we could also simply turn flux mapping off. And that's done using this button. So now all of our rays are showing again. The Poincare Sphere tool gives us a way to look at very sophisticated interplays of polarization state, flux, and wavelength in a system, and can be used to analyze sources or to analyze rays anywhere in a system, and in fact can include all rays in the system regardless of their location.